Hello all, today in this video I'm going to show and demo for SVM with the diabetes dataset, which is a CSV file. So in the for diabetes already we have done with ANN, CNN. So in the same code only we are going to continue. So only here some import libraries functions, like if you are following our channel means you may know that in the previous video we have some made the same with the same data set. We have worked with ANN and CNN from scratch, and in this video we are going to work with SVM, that is support vector mission. So the further support vector mission, only some libraries is used. The main library which is going to be used is SVC, which is mainly used for support vector mission. And for calling the CSV dataset, we have to load the library like pandas from import pandas as PD. That only we are using here, and we are just displaying the value of the dataset, and then we are describing the dataset. And if there is any null values means we are displaying them also, and then grouping this is the data set details, and this is the SNS plot for the data set details. Now we are just dropping the date time value from the data set. See, here we can just see with the initial data set, here the date and the time value, you can see it is like 800. The Python will not accept inputs like this, so we have to drop this date time value. So we are just dropping it. For that we are just using the function dot drop as in line 12. Then we are just declaring two variables like x and y. The x, if first we are dropping the datetime. Apart from datetime, every values other than value is made within the x variable, and y, which will just take the value. Here this is will be found in the data set. Here you can see this value will be taken in the y data set, and other than this patient ID and code is taken will be taken in the x data set. And we have to predict this value only. For that we are going to split our data set into four variables like x train, x test, y train, and y test by using the train test split function. And here we are just splitting into 80-20 percentage, that is we are setting the test size to 0.2. That is our testing percent will be 20% and training will be remaining 80%. So if you want with some other percent like 70-30 means, here you have to give the test size as 0.3. Then we have to since if you want to pre-process the data means, for that pre-processing I'm just using the standard scalar function. And with this, by using this scalar, we are just reforming our x train and x test data set, and then we are determining the shape of the x train and y train. This x train and y train shape we will be using in the ANN and some neural networks, because in that the input shape will be also an input. So for that we are just displaying it. In this SVM we no need to know the shape of the x train or y train and all. So this is the code for SVM. So for SVM we are just using the SVC library, and the kernel we are using linear. It has some different kernels. So if you can work with all different kernels, and you can just confirm which kernel is providing the better function. For me, I just choose linear. If you want to choose some other kernels means, you can just use them. Then for we are just training it with using the x train and the y train variable. In that XVM classifier value we are just using to predict the values, that is testing. And then we are just plotting the confusion matrix and also curve. And then the other performance metrics parameters like precision, recall, and F1 score. So this is the output for SVM, the confusion matrix, and also the other parameters like precision, recall, F1 score, support, micro average, macro average and also weighted average. You can see our accuracy with the SVM is 69% for this diabetes data set. This diabetes data set we just downloaded from Kaggle. So in the next code with the same data set, we will just show and demo with hybrid SVM and CNN. Thank you.